Welcome to the PrairieLearn Pico emulator configuration video by Team SDMA24-33. This is the second video of the PrairieLearn Pico emulator series, and we recommend that you watch the overview video before continuing. In this video, we will go over the installations and configurations needed to use our emulator if you would like to do it on your own. This includes creating custom C code and executing this custom C code. Some important notes to know before going into this video is that this video covers configuring the existing repository as it is currently set up. We recommend that you please see the written documentation for configuring the emulator from scratch if you'd like to do this in your own separate repository or would like to understand more about how it works. It is also recommended to use the script in the overview video instead of doing this, as it is much simpler. However, the script may need to be modified, or you may find that this is more useful for your application. Before we begin, please run the following commands and pause the video. Installing Visual Studio Code before we begin is also essential and is used by those last three commands where code is the command used. We will take a pause here and let you install these commands. This is needed as these are all the utilities that you will be using during this video. After installing everything on the previous slide, if you have not paused and done so, please do that now. Moving on, we will go to the demo. We will show how to set up the environment, how to create the custom C code, and how to run this custom C code. We will now move into our Linux VM and pick up from the SDMA folder with the emulator directory inside. If you have not already cloned this directory, this is also needed. Going in, what we will do today is walk through essentially what is done in our write-up of the written documentation. Like we have said, if you would like a more in-depth analysis, please go follow that write-up. After installing all the commands we have before, first we're going to need to edit a certain file. We're going to use nano with sudo permissions, and we are going to edit the ./.bash rc file. You're going to enter your sudo privilege command, password, and scroll all the way down to the bottom of the file. Note that your file may look different from mine as my environment has been set up differently. The line export Pico SDK path needs to be configured for your VM. If you open up our files, as you will see, within the SDMA folder, the emulator directory, we have the Pico SDK directory. This path should be the directory to it. One simple way to do this is to open the properties and find your file location. For you, it should be very similar to me, where my username mgram is replaced with your username. If you have cloned the directory anywhere other than your home directory, this will be different. Go ahead and make sure you save this and exit. Now we can open up Visual Studio Code. We're going to go to File, Open Folder. We're going to select the SDMA, Emulator, and Build Hex files. We're going to open this up. You can likely clear any prompts that appear on your right side. From here, we're going to find the build hex files.c file. As we can see, hello world is in here by default. I'm currently going to leave this in here for the purposes of this demo. However, if you would like to modify it, feel free. Instructions on how this works and modifying it can be found in the overview video mentioned previously. Please note, if you would like to use standard C code and you would like to print a standard output, the following line must be the beginning of your main. This line on line 9 initializes the standard input output. This would be if you would like to use things like printf or scanf. For our purposes, we're going to use the customized UR functionality and will not need this. So, now that this is done, we can go ahead and select the build button in the bottom left. You will see in the terminal that everything will be built and you will get a finish with execute 0 if successful. This is different on my end as I have already developed this before. You may see a panel up at the top such as this command palette here, that will ask you to select a kit. When the kit is selected, please select the GCC 10.3.1 ARM None EABD option. This is the same option we saw in the slideshow right here. Please make sure that you select the proper kit. For more information, please see the write-up. Now that this is completed, we can open our files and we can navigate to the SDMA, Emulator, build.txt files, and build directory. Inside of here, we're going to find the build.txt files.hex file and copy it. Returning to our emulator, we can then go into the rp2040js directory. As you can see here, this file is already here, however this is an old version from the repository. Go ahead and paste in the file and replace. Next, we can open our terminal again. We're going to want to cd into the rp directory we just were in. Now, we are going to run the following command, npm install. Please make sure you installed npm as shown earlier in the slides. This is going to configure everything that we need, and we're going to wait for the terminal to be ready for us. Please ignore the one high severity warning, as it is something that is part of the repository. We can also run npm start. This will then print our output to the console. This can be ended with Control-C. As seen in the overview video, this is the manual version of the script run, whereas we output to the console here as opposed to the text file shown within the overview video. In conclusion, what we saw today was how we use our existing repository to use our emulator that has already been configured. This also shows how to do the basic configuration needed if you would like to run it on your own system without using the script. Like we said, we do highly recommend using the script instead, as it automates the process and makes everything a lot easier. Using that script, you will not have to do the installations, configurations, or manual running of the code. And you can modify the script for whatever usage you need. If you would like more information, please see the written documentation linked within the description of this video on our official website and within our Git repository. And also, please see the overview video and the next steps video for the overview of the emulator, as well as the next steps that can be taken for implementation and for improved functionality.